Hi, welcome to Physics
After Hours.
So things are going to be taught a little bit different this time around, so I hope you enjoy.
Alright, hi. Okay, let's get into our question. Our question states that we have a 0.3 kilogram oscillator that has a speed of 95.4 centimeters per second at a displacement of 3 centimeters for the first point and 71.4 centimeters per second at 6 centimeters for the second point, and it's asking what's the oscillator's maximum speed. So to be able to find this, we're going to model these 2 points as a spring and a mass to find the spring constant from the system, and use that spring constant to find the total energy in the system between 2 points together, and then find the max speed from that total energy with the assumption we have later in the video. So for our first step, we know that total energy equals kinetic energy plus potential energy, and here's our equation right here, which is kinetic right here and potential right here. So we use this equation and plug in the respective points for our first point and our second point. So keep in mind also that all the centimeter points right here, which is the velocities and the displacement, I converted to meters, which is just moving the decimal point to the left 2 times. So for our first point, we have 1/2 times our mass right here, which is the 0.3 kilogram oscillator, times 0.954, which is the velocity transmitted to meters for our first point, plus 1/2 times k times 0.03 meters, which is our translated point from 3 centimeters. Same thing with our second point right here, which the same numbers because we have the same mass but different velocity and displacement translated to meters as well. So we have these 2 equations, which is our first point, and our second point, which is the energy for those 2 points, and we're gonna continue to our next part to see how we find our maximum speed. So due to the conservation of energy, there's no energy loss in the system, and that helps us because now we can calculate the maximum speed for the whole system, because we could just equal those 2 parts together, those 2 energy points together that we got from our last step. So we have our first point equation and our second point equation right here, and we just combine like terms right here to get this number equals this number times k, and then we divided this number by this number to get our k, which is 44.48 Newton meters. And that's for the whole system between those 2 different points of the oscillator. And now that we have the k, we can plug it either into the first equation or the second equation from the last step as well to be able to find the energy in the whole system, because like energy doesn't leave the system or come back into the system. So I just plugged it into the second equation, which has our k right here, and we got energy equals 0.1565 joules, and that's the energy in our whole system. So here is our theory right here. I was kind of confused, but I searched it up, and it turns out that speed is max when the total energy is all kinetic. And you could kind of see that right here, when you could see when the ball's at its maximum speed, it's around the middle. And then when it's at the middle, you could kind of see that the kinetic energy is taking up all the energy in the whole system. So I just have the whole kinetic energy equation right here, and you plugged in the respective points. K equals all the energy in the system, because all the energy is the kinetic energy, equals the 1/2 times the mass times the V max, and that's what we're trying to find. We just isolate the variables at this point and square root the other side since it's to the squared, and we've got 1.021 meters per second, or 102.1 centimeters per second, which is our answer. And that's all.